this is the example that I want to explain. It's an example using what we know about the unit circle to find all the trigonometric functions of any angle. So we'll just do A. The first thing we have to do is convert the angle in radians to an angle in degrees so we know what quadrant of the unit circle we're dealing with. So when we do that, we get in 270 degrees plus 45 degrees. Now on the unit circle, that's going to be in the fourth quadrant. And in the fourth quadrant, the x-coordinate is going to be positive, the y-coordinate will be negative, and the referent angle is 45 degrees in the first quadrant. So now we have everything we need to know. Once we locate the angle 315 degrees on the unit circle, then we use all the information that we have from the unit circle to compute all 6 trig functions. So the cos is going to be, the cos of the angle 315 is going to be the x-coordinate, and that's root 2 over 2. The y-coordinate is going to be the sine, and that's minus root 2 over 2. And then tan is just defined to be the sine over the cos. So we get the two values that we have on the left-hand side of this page, root 2 over 2 and minus root 2 over 2. And when we take the ratio, we just get minus 1. And then cotangent is just the reciprocal of tan. So that's that's 1 over minus 1, which is minus 1. Cosecant is the reciprocal of sine. So since sine is minus root 2 over 2, that means we get minus 2 over root 2, which is just minus root 2 when we rationalize the denominator. And lastly, the secant is 1 over cosine. And since cosine is root 2 over 2, then the reciprocal is 2 over root 2. And again, when we rationalize, we get root 2. So it's not complicated. As long as you have the information that we dealt with from the unit circle, then you're golden to deal with any angle between 0 and 360 degrees that you could possibly want.